At the heart of any dynamic experience is conditional logic. Conditional logic is the way in which we tell our patches and our programs to make decisions based on input received. The most simple kind of conditional logic is to test if something is true. So we would say, if something is true, do action A. As well, we can add another statement, if something is true, do action A, else, if it is false, do action B. We'll deal with just the former, which is if something is true, do action A. In this particular case, we're going to make a patch that's going to send out a perfect fifth between E and B as a dyad. And if a number is equal to 100, then it will play that dyad, else it won't do anything. So let's create the simplest part, which is sending out E and B. So I'll make note, add a velocity of 64 and a length of 250 milliseconds to note out channel 1. Okay, we'll need our dyad, so that's going to be 64 and 71. And if you don't know your MIDI numbers, you can just search online MIDI note numbers and you can get a chart. There are many sources of information for MIDI note numbers as they correlate to keyboard. So let's create a trigger. Again, this is a bit of an obsession of mine to create triggers to make sure things bang in the right order. I'll compress the space here because this is going to get a little big. And then finally, I need a bang to get both notes to play at once. Okay, so the idea is that I'm going to test for a number equaling 100 in order to send a bang, otherwise it won't send a bang. So if the number is 100, I'll get the notes. If it's not, I won't get anything. To do this, we'll use an object called Spigot. And we'll connect that to the trigger. And let's create a number atom on the side so we can see what Spigot is sending out. Now, the two inlets of Spigot are like so. The rightmost inlet is the gate open, gate closed. So if it receives a 1, the spigot is open and data will flow. If the 0 is received in the right inlet, the spigot's closed, no data goes. So let's just simply send a message of 100. And then we'll create a message box equal to 1. And a message box equal to 0. By default, Spigot is closed. So if I click the 100, nothing happens. If I click 1 in order to open the spigot, then the 100 has passed through. And here it's really just acting as a bang. If I close the spigot, then nothing passes. So now I need to create a condition to test for the number 100, because I could just create a message box that has it, but that isn't actually testing for the condition. So I'll delete that message box and these two message boxes. And I'm going to use the equals conditional operator. And we can look at the help on this, and we get this relational operators help patch. So you can read that if you like. We won't read it now. And we'll create a number atom at the top. Okay, we'll slide numbers, and then when we get 100, the idea is that it'll actually play the notes. Let's take a look at what this conditional operator is outputting. So we'll create a number atom and connect it to the output. And before connecting it to our main patch, let's test it out. So as I slide the number upwards, nothing's happening here. It's just 0. And then when I hit 100, I get a 1 and then 0. So the idea is that it's sending true, false. 1 equals true, 0 equals false. If the number is 100, send a 1. Otherwise, send a 0. And it's important to remember that this thing is actually banging as we slide the number upwards. Okay. So that's an important detail there. So since we know it's sending 1 for true and 0 for false, then what we can do is we can connect it to a number atom just so we can debug it, connect the number atom to the spigot open and close inlet, and as well, since it's going to be banging, let's send it to the hot inlet of spigot. It's essentially functioning as a bang, if you will. So now, as I move this up and down above 100, nothing happens, but as soon as I hit 100, it bangs. So the condition here is if the number received equals 100, then send out. Else, do nothing. So let's change the conditional to a greater than 100. Now the idea is that for every number above 100 that we slide, we're going to get a bang. But as soon as we're below 100, we get nothing. So that's one way to create conditional logic, and this is just an if. It's if this is true, do something, else don't do something. So now we'll take a look at the case where if something is true, do action A, else do action B. So let's delete all of the patch above the spigot. Okay. And why don't we say this? If the number received is greater than 50, then play the E and B, the 64 and 71. Else, if it's less than 50, then let's play C and G. Okay, so since we're going to have to play C and G, we need message box for 60 and 67, because those are the note numbers for C and G. We'll need another trigger. Well, actually we don't, but let's just go ahead and do one anyways. And then connect this to make note. Okay, we'll need a bang for both. Okay, and the idea is that if it's greater than 50, play 64 and 71. If it's less, play 60 and 67. Now for this particular condition, this is an if-else condition, we're going to use an object called Moses. And the creation argument for Moses will be the point at which it's true or false. So we'll type 50. And so if the number is equal to or greater than 50, it will bang out of the right. If it's less than 50, it'll bang out of the left. Now I forgot if I was going to say greater than 50 would bang E and B, but since it's lined up, let's just go ahead and do that. And less than will bang 60 and 70, or 60 and 67 rather. Okay, fantastic. Let's go ahead and hook up number atoms to the outputs just to see what these things are outputting. You know, are they outputting true false in terms of ones and zeros? Are they outputting the actual data, a bang? All right, now let's hook a number slider up to Moses. And so we see that it's actually outputting the number. And as we approach 50, so if the number is less than the number in the creation argument, bang to the left. If it's greater or equal, bang to the right. It's actually really helpful that way. We could have used something like, let's see, we could have said greater than 50, less than or equal to 50. We could have, or I'm sorry, just less than 50, not equal to. It's greater than or equal to. We could have done it this way, but since there's an object that really quickly does it for us, let's use it. So Moses will send to the left and the right, depending on a midway point. And as you could guess, the inlet of Moses will change the point at which it bangs to the left or the right. So for instance, if I create a message box of 75 and I click that, so now if the number is greater than 75, bang to the right, less, bang to the left. So those are two ways to create really simple conditional logic. Use Spigot when you want to open a gate based on a condition, and use Moses when you want to send to the left or the right or have a really simple binary choice in order to send out two different outputs.